Hello, hello, hello. And this is week 5, that is graphics. And in this graphics, we'll know multiple things that are very different, very new for us, and especially in Python. So we'll be able to create, graphics using Python. No photo editor, no nothing, no paint, just Python. All right, so this is the lesson graphics. You can go through it. It takes 35 minutes. Let's start. Yeah. So Karel says, like, by the end of this lesson, you will be able to create a graphics program, draw shapes on canvas. Let's continue. This is going to be a video and we are not watching it. But let's get the textbook. All right. Graphic shape. All right. So this is our textbook as usual. And over here, we are in graphics module. And this is our basic shapes and this is animations. All right. Now, basic shapes. You should go through this where we learn about how to create a circle, how to create a rectangle, a square, a line, and how to draw an image. Like the image is already there, but you're plotting it on the sort of graph. All right, how to plot your text, everything. So yeah, this is CLI, but this is something called GUI. So it's a graphical interface. It's a command line interface. Now, Python graphics is an actual library that you can import from graphics and then import canvas. Now, canvas looks like this. Now, to get an idea around why this, what is this? Yeah. So I have prepared well graph papers for you. So let's bring out a pen and paper. Well, this is a paper. So let's continue. All right. So this is a paper and what is actually happening to us. So this is a paper and what is actually happening. So when we used to, create our X and Y axis, what we used to do was, well, we took a origin point anywhere on this paper and then started plotting X like this horizontal line and well, Y like a vertical line, isn't it? So this is what we used to do and we well named it X and Y. This is our Y coordinate and this is our, let's say, X coordinate. Not let's say, but yeah, this is what we assumed when we were creating graphs for a paper in maths and all. Now this starts from 0 0. Like over here it's 0 comma 0. Why 0 comma 0? The first one we write is our x-axis. So over here x-axis is also 0, and the second thing that we write in a coordinate after comma is a y-axis, and y-axis also is 0 at this point. If you can see at this point over here. Yeah, so at this point, the origin that I've highlighted. Now, it should go well till the infinity. That's why there is an arrow. There's an arrow. It's like a ray. And ray starts from a point but goes till the infinity. But we have a finite amount of display in our case as a monitor. So we are deciding some sort of height and width. So height, well, this looks logical that this should be a height and we are limiting it to some point. Let's imagine this as a point where we are, limiting our height. It should not go till infinity. Otherwise, it will be plotted somewhere, but you won't be able to see it. And the second thing that we are limiting is our x-axis so that, yeah, it doesn't go out of the width or the breadth. So yeah, x-axis is a width like this. So now inside this square, you can, plot anything and you'll be able to see it. All right. This is your graph paper. But in our case, this whole thing is upside down. So there's nothing I could rotate to, but let's do it anyways. So what's happening in our case as in monitors, Let's take this point as an origin. So what is happening is this remains our x-axis as usual, as a horizontal line, but the vertical line has been changed. It's now upside down. Now this is our y-axis, not negative y, but actual y, the positive y-axis. So now what? Now this is, let me write it. This is our y-axis now. This, as usual, is our x-axis, and this point is, well, 0 0 0 comma 0. It still indicates the same thing, that 0, our x-axis is 0 over here. At this point our x-axis is 0, as well as after comma we see again a 0, which means our y coordinate is also 0 at this point. Now we also have to limit it somewhere, so we limit it, let's say, at 100 or 200 pixels. So let's imagine this is a 100 pixel, so let's limit it till the 100 pixel, and for width as well we should limit it till 100 pixel, like this. Now inside this square you can plot anything and you'll be able to see it, otherwise you won't be able to see it. So that's it. That is it actually. So shall we go back? So this is exactly what you see. 0 0 0 is our x-axis first of all, and the second 0 is our y-axis coordinate at this point. This point, that is your origin, isn't it? And after that x goes on till you limit it, and y goes on till you limit it. All right, so when we pass the canvas argument, which is like this, it looks like this because we only need the limiting point. Otherwise 0 0 is actually fixed at this point at a corner of a canvas. It's already fixed. What we want actually is a point where we can actually stop. So it says, well, for x-axis you can go till 800, so our width is till 800, so it's long, and y-axis it's 200, so our height is quite short, so it will be somewhere around here. And x-axis, so inside this rectangle that I'm trying to let's not try, let's create. Yeah, so so y-axis is limited to 200, let's say. So this is, let's imagine this is a 200 point, and x-axis is limited to 800, so let's imagine this is a 800 point over here. Now inside this rectangle you can create anything at all and you'll be able to see it, and that's a canvas. If you go beyond this point, now you might ask, where is the point? Well, we are seeing boundaries, but where is the point? Point is actually this point is actually called the canvas that we are passing. So the canvas we are passing is 800 for x-axis and 200 for the y-axis. So this is our coordinate actually. This is a point. Now what do I mean by that? Well, it's nothing extraordinary. If you think about it, x-axis is 800 at this point and the y-axis is 200 at this point. So it comes and meet at a single point. There cannot be any other point on the graph where x-axis will be 800 and y-axis will be 200. It can be 201, but not 200. So this is our only one point. So if you say x and y all together, x coordinate and y coordinate together, you actually get a point. So yeah, that's an important point to remember that when you write something in this format, 0 0 or 800 200, you are actually creating nothing but points. So now I ask you, what is a point? Well, to answer that, point is nothing but two coordinates, that is x and y coordinates, coming together to specifically point us to a location in our graph. So that's a point. So when we say 800, x-axis is 800, well, it goes long way. Like this is 800, this is 800, this is 800, and it can go on till infinity, isn't it? There are 800, like many points on 800 at x-axis. It can go on. And for 200 as well, it can go on, well, as well, forever. It can go on and on. So this is all 200 for y-axis, isn't it? But 800 and 200 written all together, it intersects at only one point where we get this single point that is called 800 and 200. We don't get this point anywhere else. Remember that point. Now, 0, 0, again, the same thing. 0 for x and 0 for y. There are, on 0 of x, you are plotting the whole y-axis, if you think about it. Because x is 0 over here, and if you don't specify what is the y, you can go along this y-axis forever. And yeah, that's a 0 for x. But if you specify y like 1, 2, 3, then you would get a finite point. So to get a finite point, you actually need x and y-axis all together. So if you are giving coordinates like 0, 0 and 800, 200, you're actually able to create 2 points. You can see 1 point over here. Hey, so 1 point is over here and the second point is over here. So this is sort of a starting point, or we say origin in a graph, and this is sort of an ending point that we say as a, well, ending point. Nothing fancy about it. And all these things inside it is like a boundary that you have to, consider. You can't go beyond this boundary. If you go, well, you can plot something right over here. But since canvas is limited to this much amount of this rectangle, it cannot see what this point is. Even if this point is legitimate, like let's say 50 and something like 300, isn't it? So if you plot something like this, y-axis is limited to, let's write it down, 50 and, oh, whoa, whoa. Let's write this point as 50 and 300. Now, if you think, what is 50? 50 is for x-axis, and you can go there for x-axis. You can actually go. So 50 is legitimate point. You can go there, but it goes till infinity. So if you don't define what the y-axis is, it could be anywhere. Like it could be over here for 50. It could be over here for 50. It could be over here. But you were quite, over smart. So you went beyond what y-axis boundary was. So what was the boundary for y-axis? It was 200. But you went beyond 200 to approx 300. Now you have actually plotted the point, but you won't be able to see it because canvas is limited to 200 only. So you won't be able to see it until and unless you can actually, move this point somehow to 300. Then you probably will be able to see this. Otherwise, well, no, that's not going to happen. Okay, so I imagine that this plot is clear. Now inside this plot, you might also catch something about rectangle. What is it? This plot actually looks like a rectangle to me. If you think about it, if you plot a rectangle, this actually looks like a legit rectangle for us. And inside that rectangle, you could do anything at all. Isn't it? So if this is actually a rectangle, so now tell me, how many points do you require to plot a rectangle? Well, if your answer is 2 points, then you are correct. If your answer is other than that, you are not. For 2 points, what do I mean by 2 points? Let's say we are creating a rectangle of the size, full size, like the size of a canvas. So we have created a rectangle starting from 0, 0, which means 0.1. So this is our 0.1. If I can write it, this is our 0.1. And it is ending or going till the end point, which is our 0.2. So we've got 2 points, and in between 2 points, we are actually able to plot a rectangle. Isn't it nice? Well, it is, if you think about it. Now, what the limitation is? Can you tell me? Well, if you think about it, if you don't plot 0.2 over here, if you try plotting 0.2 over here, which is also looks like a corner, legit corner, but if you try to plot 0.2 over here, you won't be able to define the x-axis or where the width should end. Should it end over here, or should it go beyond, or like where should it end? Or if you try creating 0.2 over here, you won't be able to define what the x-axis is. Sorry, what the y-axis is and where it should end. Should it end over here or over here? That's why we have defined, both of point 2 at this corner where x is also defined, y is also defined, and they're intersecting at a point. So I don't think there is any drawback. Now the thing to notice is the point that we say point 1 and point 2 are actually nothing but coordinates. So point 1 is a coordinate and point 2 is a coordinate. Point 1 contains coordinate of 0, 0, which means x and y, x coordinate and y coordinate as 0, 0. And point 2 contains another coordinate that is 800 and 200 as, x is 800 and y is 200. So I think that's it. We are able to create rectangle. We know points, we know x and y coordinates, and let's try creating another circle, shouldn't we? Well, let's go. So let's imagine this is a point 1 over here, and we start to plot another rectangle. So from point 1 it goes till here, that is a point 2. Now inside this canvas, this whole canvas, that's a big rectangle, we have created another rectangle, a small rectangle. Now if you think about it, how did we do it? Well, we required point 1 that can be specified by x coordinate at this point. Let's imagine it's 50, isn't it? And the y coordinate, let's say something like 20. And this point can be defined as the x coordinate as 150 and the y coordinate as 100. Let's do that. So we've got 2 points, that is one right over here, one right over here, and we can define a rectangle. What about a circle? How can we define a circle? Now, when you are plotting a circle, you can see something very interesting. Circle is inside a square. You cannot create circle outside of a square. But if you try creating a oval, you will have to create a rectangle, and inside that, if you create something, it's like an oval or ellipse, isn't it? So if it's a square, you get a circle. If it's a rectangle, you get an oval. So in basic shapes, we can create an oval. And if you create oval such that it looks like a square, then you have actually got a circle. Now, what do I mean by that? Well, the circle has disappeared, but let's still. Let's imagine this was our circle, what we were trying to plot. So to create a circle, we need to actually plot a square first. So square also requires point 1. So let's imagine this is our point 1 for our square, and this is a point 2 for our square. So we've got a square. There's no problem at all. Now inside that point 1 and point 2, you can actually create a circle. Otherwise, you cannot. So you can actually create this circle, which is nice. Otherwise, you would create something not like a circle at all. So now we know even to create a circle, you first of all have to create a rectangle or a square by defining the point 1 and point 2, which means you have to define 4 coordinates for point 1, x1 and y1, for point 2, x2 and y2. So shall we write it like a variable? So for point 1, you have to define first of all x1 and y1. And for point 2, you have to define x2 and y2. So I think this much is clear. We shall go back to coding. That's it. This is it for, understanding part. Yeah, something is left, that is line. So line starts from a point, ends ends till a point. So you just have to define 2 points again, which means 4 coordinates. So all these shapes like square, circle, rectangle, a line, or even a text, which is nothing but inside, a square or a rectangle, written something like this. So for all these shapes, all these things, you just have to create point 1 and point 2. And point 1 is nothing but x1, y1, which is our point 1. And point 2 is nothing but x2, y2. I hope that much is clear, because I'm going to use x1 and y1 very, very much. So if that's not clear, you won't be able to catch up with me. And if you're already well familiar with basic maths, then you can move on. Now, so canvas, what was a canvas, this argument doing? I have well told you all. So after doing this, we actually get a canvas where our x-axis looks 800. Well, this width looks 800 to me, and this height looks 200 to me. So yeah, this is legit. Now basic shapes. So we can create shapes using something like canvas dot create line, and we can store it in a variable like line. So it draws a line by giving it x1, y1, x2, y2, and a color. Color is by default black as well. So we've got something like this. Now we've got another command that is create rectangle, which requires x1, y1, x2, y2, point 1, point 2, and a color. Even an outline. We can define an outline as well. So we've got a canvas. Now for oval as well, we've got x1, y1, x2, y2, which means point 1 and point 2, and a color specifically so that we can specify the color for that oval, and we've got an oval. Now, if we try giving it the same point, we can actually understand how the oval is created. It is created inside a rectangle, obviously, but we are showing rectangle as well by creating a rectangle with the same coordinates and creating an oval with the same coordinates. And we can well see how our oval is actually created. It's nothing but a rectangle, a circle inside a rectangle, or an oval inside a rectangle, isn't it? Now drawing text requires font, font size, colors, anchor. What is anchor? Anchor is a string, one of n, ne, e, se, s, sw, w, nw, or center. Now that describes what side of your text you want to position. Like at x, y, you provide. So the font describes the style, the size of the text. For example, like Helvetica 32, that is like font and the size. And the text is a text string you want to appear on the screen. So whatever you want to appear, like my first text will appear if you write it inside the text argument. The font size, you can write it separately as well, like this. You give it a coordinate and you've got a text. So for text, we are actually only defining the starting point of the text. And as for the rest, it goes on depending upon the font size, the text length, and it automatically ends, isn't it? So the text is the string you want to appear on the screen. And here's the sample. Well, we've already gone through this, where the color is blue. Text is my first text, which is visible to us. The font size is 50. Font is Arial, and our starting point, or the point 1, is 50/50. All right. Now we can even draw polygons. And now you can see, to create polygons, we might need more than 2 points. So we are actually getting more than 2 points. That looks like x1, y1, which is our point 1, x2, y2, another point, that is point 2, x3, y3, let's call it point 3, and so on. So we can create a polygon out of it. So if we define x1, y1, x2, y2, x3, y3 for a triangle, and if we run it, we actually get a triangle. And to create triangle, we are saying create polygon, and we are actually passing all these points, that is point 1 with x1, y1, point 2 with x2, y2, and point 3 with x3, y3. And we are actually getting a polygon, that is a triangle. We can create a pentagon, hexagon, decagon, whatever. Now to create an image, you have to specify the top left, the left x, the top y, which is nothing but x1, y1, and you can just give it a file name and it will, do everything automatically. So you're just giving it a point, or the left corner point specifically, and the right corner point, right bottom one, that is x2, y2, or point 2, will be defined automatically according to its width and height. If you want to specify that as well, it will be calculated automatically, because this function gives us that so this function gives us that facility. So it's nice. Otherwise we would have to calculate if this is our starting point, if this is our width and height, what should be the ending point. So well, this function said let me just give you the starting point and width and height. You can just define those, and we can handle the rest of the calculations for you. So what is actually happening is nothing, but if our left x is something that we have defined, that is starting point, the width will say this should be our ending x or x2 after adding it to left x. So left x is, let's say, 50. And if we add 50 to the width, we actually get somewhere that should be our x2. Now to get a y2, we just take the top y and we give it a height or add it to it, and we actually get a y2. So if top y was 10, if we add height to it, we'll get a y2, and x1 x2 y2 wherever it intersects is a point 2. All right, and the file name is whatever the image we have stored or we want to plot. That's it. Now to remove objects from the canvas, if we have created a, let's say, rectangle like this with x with point 1, point 2, we can store it in a variable called rectangle, like we always do. So now, since this is sort of an object, isn't it? So we can create an object, we can also delete the object. So this variable is storing something called object. So now you can actually delete that object using the delete method, I would say, that canvas provides. So you can go like canvas.delete and whatever the rectangle is, the variable, and it will actually delete the rectangle. And it says, note that deleting an object is permanent. So if you want temporarily make an object hidden, use the set hidden so you can pass it either true or false. So if you delete a rectangle, it will be deleted automatically. So, in the letter code, you won't be able to get this rectangle or access this rectangle anymore. But if you say something like rectangle set it to hidden or set hidden is true, then this is no longer visible, but you can access this rectangle variable later in this code. You can say, well, now is the point where you show me the rectangle and it gets visible again. Now there's object ordering. So what is this? So objects are drawn on the canvas in the order in which they are created by your code. So if you draw a blue triangle after green square, the blue triangle can potentially cover or, well, occlude the part of the green square. So this is sometimes referred to as Z orders of the objects, which means, okay, let's take this code. So we have created rectangle first, and over that we have created an oval. So you can see the oval is overlapping the rectangle, but we are not seeing the rectangle. We are seeing the oval because it is created after the rectangle. All right. And the text is created after both of these shapes. So we can say, we can see the text on top of both of them, like on top of this rectangle as well as on top of this oval, isn't it? Now changing object color is as simple as passing that variable by saying set color and the variable rect and whatever the color we want by separated by a comma. That's it. And we can also set outline color, which is our another another argument or another parameter that's optional. So color and outline color are optional, but we can set them, we can create them, we can play with them. So if you want to create outline color as well, we can, after writing yellow, we can write black after comma, and it will actually give us a outline of the rectangle. But over here we are changing the color, or setting the color to red, and over here we are setting outline color to blue, and these are valid things that you can do with your rectangle. Now it says if you don't want to choose a color yourself, you can get a random one with random colors like this. So there's actually a get random color function in canvas as well. So you can get a random color by saying something like this, isn't it? And after that you can actually set this random color variable after getting, let's say if you call this, and for once it gives you, let's say, red color. After you run it another time, it might give you a blue color, but let's say for this runtime, it gives us the red color. And we are storing that red color in the random color, and we already have a rectangle over here. We are passing the random color that is red for now in set color, and it will set a rectangle's color from black because there's nothing specified over here. So it automatically creates black rectangle to whatever the random color that is given to us. In this case, red. All right. Now you can go through all the list of the colors that are there. Whoa, this is actually interesting. Like, these are so many names. So if you want any sort of colors, just take these names and you'll be able to get this specific color. And it's TK or Tkinter. Well, I would like to call it TK. So to use this graphics library, you just have to say TK install TK however you want. Like, I'm using Linux, Arch Linux, so I have to say sudo pacman -s and TK. But in Windows, there might be some other ways you can download TK. It's sort of a Python library, so you have to get it somewhere. You can also try doing pip TK. Sometimes it works, sometimes it doesn't. Like in my case, it didn't work, so I have to install through pacman library. Now, that's a different technical discussion, but there are so many colors, and I'll probably link this website as well. Now let's end this textbook by seeing what the graphics object is. So getting information about the graphics object or the objects, so you can ask the canvas for the information about them. For instance, you can get an object dimension via saying something like get object width or get object height. So if you have specified object width and height as 0.2 from 0 0, because 0 0 is origin, so it will actually just say 50 and 100 for us. But if this was, something like 10 and 10, let's just say x1 and y1 are 10, then we have to actually calculate, which means 50 minus 10, which is now 40, 100 minus 10, which is now 90. So now if we say get object width for the rectangle, it will give us 40 in our case. But in this case, it gives us 50. And get object height rectangle, it gives us 100 because the origin is 0. If it was 10, 10 and 10, which is not origin but a 0.1, it would give us 90. Like, it calculates, all right. It subtracts the x2 minus x1 to give us, the width. And it subtracts y2 minus y1 to give us a height. I hope that's not confusing because I have told you what x1 and y1, x2 and y2 is. So yeah, that's why I've told you, because I'm going to use it multiple times in this video. Now for oval, what we can get is the left x and top y. Not for oval, but for rectangle as well, but we are creating a oval and we are seeing that. So it says you can also ask canvas for information about object's location, specifically if you can get the leftmost, x coordinate of the object or the topmost y coordinate as follows. So if this is very intuitive for you, like left x, top y, and right x, bottom y, something like that, if that's intuitive for you, you should follow that as well. Now, moving graphical objects look like this. If we have a rectangle at point something like this, we can move it by giving it another point and saying, well, move it. So it says move to, and we are passing the rectangle, that is our object, and we are passing another coordinate. So how this works is you can change the location of the object using move to. We know that you specify new x and y coordinates, which will be upper left corner of the bounding box for the object. And here's how we would move a rectangle to have an upper left corner at 25 and 50. Now it says you can also change the location of an object by specifying how much would you like to move it by, instead of just specifying the new locations. So instead of saying move to, you can just use move. So the move function lets you specify the change in x and y in the object relative to its current location. Now, for example, that's how we would move a rectangle 5 pixel and 10 pixel down. So it will move our rectangle by 5 pixel right and 10 pixel down. Okay. So that's it for our basic shapes. And then we would go to animation, where we are just using time and then moving our shapes regularly at some point of some interval of time. And that's it. So we are importing to the time library, and we are saying time sleep, and it will sleep for a certain time very quickly, and it will move in a loop sort of. And we'll probably able to see something moving, something like this. It moved quite fast. So if we run it again, yep, like this. Because what is the time interval? Delay is quite 0.001. We cannot edit it. All right. And we can create all sorts of things using animations, and we'll go through it later. So I've introduced you to the canvas and everything related to canvas. Now let's solve a problem. So this is our example code. I don't think this is a problem, but let's see. So we are importing a random library. We are importing a canvas. We are defining canvas width and height as constants at the top of a file. And we are saying, well, take the main, create a main function. Inside that, we are creating canvas of our canvas width and canvas height as 450 and 300. Starting from 0, 0, it's already defined, so we don't need to define it in canvas as we have seen it. Now for I in range of 0 to 5, what it does is it will go from 0 to 1 to 2 to 3 to 4, and that's it. That's a loop, for loop. And we are creating oval for I times 20 as a x1, I times 20 for x2, and then I times 20 plus 20, which means x1 plus 20, and as a x2, and I times 20 plus 20, which is y2, which means y1 plus 20, because I times 20 is nothing but y1, isn't it? And if we run it, we are able to see these ovals. Now, since I was talking about in x1, y1, let's create x1, y1 out of it so that it is less confusing. X1 is I times 20 as specified. Y1 is also I times 20 again. Now x2, if you see it, it's like I times 20 plus 20. So I times 20 is nothing but x1, and we are adding 20 to it, isn't it? So we are adding 20 to our x1 to get a x2, and for y2 as well, we are just taking the y1 and we are adding 20 to it. How did I get these points? Well, they're already specified over here if you see it correctly. This is our x1, y1, and this is our x2, y2, isn't it? Now let's erase these coordinate points that are written right over in create oval. And I'd like to, create point 1 in a single line like this. And after a comma, we would define point 2, that is like this. I don't think there should be any problem at all. And then we can define any colors like, black, which is already defined. So if you just want a black color, it is already given. So instead of black, let's create red. Now at the same position, it will give us the same ovals, but of red colors. And this looks quite nice to me because this is quite comprehensible for me. If it is not comprehensible to you, well, you should go back to what it was already. Let's run it. And we are seeing the same thing, but in red colors. So let's continue. Another video, we are not going to watch it. It's the same graphic shape, the same textbook, I guess. Yeah, it's the same textbook, so we won't be going through that. Let's continue. Okay, so this is it. The reading that we should go through is only graphic shape and all these optional examples that we'll probably go through, but not right here. That's all. So mark this lesson as complete. Now let's directly dig into our problems. So draw flags. Now, in this problem, we have got a flag to draw. So this is a flag that is like Indonesian flag, I guess. Yeah, Indonesia. And we already got our width and height for a canvas. We already got a canvas. Now we just have to create, well, this flag. So what is this flag if you think about it? Well, this flag is a rectangle that is of red color and another rectangle that is of white color. But canvas is already white. So I hope we just have to create one rectangle that is a red color rectangle starting from point 0, 0 and ending at point somewhere around here. All right. So let's start by creating a rectangle. So if I could say something like rect is equals to, I'd probably do it. But since we are not using this object again and again in this program, we just have to create this object. Let's directly create this object by saying canvas, not create rectangle. Now, if you're unfamiliar with what this create rectangle is, you can directly go to the docs. You can see the whole command that is create rectangle. And if this notations looks like nice to you, you could probably use these notations: left X, top Y, right X, bottom Y. No problem at all. And this color and outline are optional. All right. Okay, back to our program, and there it looks like a spelling mistake to me. Rectangle. Yep, now it's right. Now we just have to define our x1, y1, x2, y2. So let's write x1, y1, x2, y2. We'll define it later. And we need the color that is red, isn't it? Now let's try defining x1, y1. x1, let's say, starts from 0, 0. x1 and y1 is 0. Now this gives us a point 1, isn't it? So I should probably write something like point 1, isn't it? This is a point 1. This could be a point 2 right over here. This is a color, as you are already familiar with it. Now x1 we have defined, x2 we have defined, so point 1 is defined right over here. Now let's define point 2, that is x2 is equals to, and y2 is equals to. Now what should I, create? Like, what should I give the values for y2 and x2s? So let's minimize all these things. We don't need a terminal. We need a canvas. Now let's try by saying, let's say 10, and let's run it. So we've actually got a rectangle that is very small, but it looks nice. Let's make it 100. How about that? Now we have actually got a rectangle that looks like a square to me, not a rectangle, but all right. Square is nothing but a rectangle with all sides as same, and rectangle has two different sides, isn't it? All right, so this looks like a square to me. Now, because of our x2 and y2, we were actually able to create a small rectangle or a large rectangle if our origin remained the same. So for our Indonesian flag, origin actually remains the same. So x1, y1 is fixed, which is 0, 0. So it should start from this corner actually. And it should go till over here, somewhere around here, which means half of our y-axis, and y-axis is nothing but height. So we can take, y-axis as our height, that is 300 divided by 2. Half of that, and full x-axis, that is nothing but width, and our width for this canvas is 450. So let's write 450 and 300 by 2, which is 150. Now let's run it. And this looks awesome. This actually looks awesome to me. And I think we have actually created the Indonesian flag. But there might be a problem. What is it? What if the canvas changes from 300 to, let's say, 310? Now what happens? Now y2 should be, 155, I would say. Isn't it? But our y2 remains the same, that is 150. So how would we change that? Well, we have already used variables, so we could use the variable as, canvas width, that is 300 divided by 2. Now we can use it. For x2, we can directly say canvas. Oh, sorry, this should be canvas height because y-axis is height, x-axis is width. Now this should work. It's the same thing. And we've got an Indonesian flag. So if we check for the correctness, it says it doesn't match up. Okay. Okay. Why doesn't it match up? Oh, it doesn't match up because our canvas height is now 310. Let's keep it to 300 back. And we actually did it. So nice. But there's a problem. Like, not a problem, but a doubt. Like, why did we import a random library when we were not even going to use it? I don't know. I don't know why we've got this import random. All right, so since draw flag is done, let's move on. Box row. Now, this assignment is all about box row. Let's keep this terminal down. And let's try imagining what this situation is like. So we've got a canvas that we actually got it. If you try running it, yeah, this is our canvas. Now we need to create something like a square, isn't it? And how many squares? 5 squares. So we've got actually variables for those things. So canvas height and width is defining our canvas, but our n boxes defines how many boxes should be there. So there should be 5 boxes that we can count, and it is written over here as a constant. So n boxes is 5. All right. Now what should be the box size is also given to us. That should be like whatever the canvas width is, let's say 400 divided by n box, which means divided by 5. That leaves us with 80 as a box size. Now we are going to use all of these variables to actually create something interesting. So the same thing again, let's start by creating a rectangle or a square. Let's hide this assignment because we've got it. So how to do that? Well, let's say canvas dot create rectangle. We cannot say something like create square, and there looks like a spelling mistake, rectangle. Now this looks nice. Let's start by creating x1, y1, that is a point 1, and then x2 and y2. This is a ritual for me, isn't it? What should be the color? Let's say red for now. All right. So let's define x1, y1 now, and we are good to go for now. So x1, y1 is a point 1. Indentation should be proper. Let's say it also goes from 0. Y1 also goes from 0. X2 goes to, let's say, 20. Let's say 80. A big one. Y2 again goes to 80. Let's run it. And we've actually got a square. This looks nice, but this is not what our assignment wants. Let's first of all see the formatting. So it shouldn't look red. It should actually look something like white, isn't it? So if we try running it, it is actually white, but we won't be able to see it. So how are we seeing our squares? So we've actually got a white rectangle like this, or well, square for now, but we are actually not able to see it because the boundary or the outline is not black. So we've actually got another argument that we can pass through. That should be our outline, or we can just say set outline, but we'll just define it over here. That is black. And now if we try running it, we should actually get a square with a boundary. That looks like our assignment. Exactly. Now we just have to bring it to a point where it is, bring it to a point where it is getting plotted over here for 5 times. Now to plot anything for 5 times, what do we have to do? Well, we have to do all these stuff inside a for loop, isn't it? So let's start by creating a for loop. Let's say for I in range of, how many times do we want to do it? Well, I think we have to do it n times or n boxes times, which is 5. Now, if we run it, there's an issue that is colon. Now, if we still run it, we are actually able to create 5 squares, but we are able to see only one because their coordinates is same, so they are overlapping. So what should we do? Well, obviously, we cannot do anything over here because everything looks fine. What we have to play with is our x1, y1, x2, y2, isn't it? Now what to do is, well, we have to think about x1, y1, x2, y2 quite dynamically. Like how could we use the variables? How could we calculate it? And all those things. So now let's start by visualizing what we are actually doing. So if this is a thing where we have to plot 5 squares, we have to plot somewhere around here, this point. Oh, I want a square. So somewhere around this point, and it should go like a square till here, till this point at the bottom. Again, I have to start from the leftmost top corner till the rightmost bottom corner, this point 2 over here. So point 1 starts from here, point 2 ends over here. Point 1 starts from here, point 2 ends over here. And for the last one, point 1 starts from here, point 2 ends over here. So we have actually got a point. Point 1 is starting somewhere around here. What is this point? Let's calculate it. What is this? What is this point? So our point 1 should be somewhere around this line of y as a constant, because at y-axis it should remain constant. So what is constant for us? So if we say something like 200, well, I said 200, but all right, 200 will go quite beyond this y, because it will start from 200 and it will go beyond. So let's start from 150, and if we run it, yeah, we are somewhere around here, but something has shifted. You know what? Let's start by 50. You'll see something shift. So that actually shifted because x2 and y2 were here, and when we define y1 or the point 1 that is greater than that, so point 1 actually came back around here, and point 2 actually got stuck where it usually was. So we have to say this thing, or y2, x2, y2 should remain proportional to our x1, y1 somehow. So we've actually got the box size. So we can say whatever the x1 is, if we add box size to it, we'll actually get a x2. And whatever the y1 is, if we add box size to it, we'll actually be able to get our y2. So if we run it, now whatever we change to our point 1, which is x1, y1, our point 2, which is x2, y2, will be adjusted quite dynamically. Now this time, point 2 is not sticking to its earlier position, which was around here. It is actually moving. So this is our new point 2 and this is our new point 1. So, and if we shift it, this point 1 to around 150, see, this is our point 1, and point 2 actually shifted around somewhere here, that it is now invisible because it is not inside the canvas. Let's do something like 120. And this is quite like it. Like, yeah, this looks wonderful. We can see point 2, we can see point 1. And this is what we wanted, isn't it? But there looks like some sort of issue to me. Can you tell me what it is? Well, it looks like 120 is hard coded. I somehow want this point over here, this point. Let me, draw it. I somehow want this point of our y-axis. If you can see what the, image is, whatever our y-axis is, let's say 100. If we subtract this box size from our canvas height, can we get somewhere around here, this point that we actually want for our y-axis that remains constant? Can we get that? So let's try doing something like this. So we can say something like whatever the canvas height is, subtract it with box size, and we should be able to get our y1 quite accurately. And yeah, it does the same thing. Why? Because I got a point around 120, which is nothing but 200 minus the box size, which is 80 in this case. Isn't it? Calculated if you want to. So 120 actually fit our calculation. Now we are not doing it, hard-coded way. It is getting dynamic. We are not writing numbers, we are writing variables. And if these constant changes, these will adjust automatically. That's why. Now we've got a y1, which means our y will be, fixed around here at this level. We also want our x1 to vary. Right now it's starting from 0. After this one square, for the second square, it should actually start from the box size. And after that, it should start from the box size plus another box size around here. So if I say something like we have a box size, and if I multiply it with I, which will actually go from, 0, which will create our x1 at 0, which it usually was. And then it will go to 1, which will create a box size that is 80. It will go to 80. And then the I will become 2, which will create box size times 2, which means 2 box. So 1 box, 2 box. So now it looks quite dynamic. And if we try running it, we've actually got a 5 boxes. And if we tally it with our assignments that is given, exactly. So let's check for the correctness. And we actually did it, but let's just go through this code again. So our x1 is getting defined dynamically according to our for loop, which has I, which goes from 0, 1, 2, 3, 4. That's it, 5 times. y1 is fixed according to what the canvas height is and what the box size should be, isn't it? And our x2 and y2, which is 0.2, is actually dependent on our 0.1 plus whatever the box size is. So that's it. Let's check for the correctness. Let's move onwards from box rows. Now we've got a lesson functions. Let's start. So our lesson says by the end of this lesson, you will be able to, define functions that take parameters. You already know how to do that. And define function that returns a value. I hope we know that. Well, no videos, but let's go through textbook. And we have got the same textbook again, but now this time for a function, and it says anatomy of a function, the scope, the parameters. Now you can go through that, but we probably won't be using that much of a function, scope, and parameters. But yeah, you can go through it. It's an interesting read, and I hope you can finish it by yourself. It is nothing but the function that we already create, but now we can we can return something out of this function. That's something Python uses to return a value back so that we can, use this function and assign whatever the value it returns to a variable, or sometimes not store it in a variable, but actually print it. So over here, what are we actually doing? We are printing it directly, but we can store it to a variable and print it. Same thing. And scope is nothing but, the indentation that you're actually doing creates the scope. So for I, now, the I is a variable that you're using inside a loop. And this is only limited till the loop. And after the loop ends, there is no I variable that you can access. But inside this loop, after this indentation, you can actually access the variable I. All right. Now this n that is over here, you can access this access it anywhere inside this function, but outside of this function, this n is not accessible. All right. So that's scope for you. Now parameters. So there is arguments and parameters. So while creating a function, you actually create parameters that you create your function based on. So if you're creating numbers, well, this is a parameter that you can, use it to create the rest of your function. But when you use that function to call this function somewhere, where are we calling? So when we call this function around here, is even, it is actually getting an argument. So this thing is an argument. The thing it is taking is a parameter. All right. Okay. And I will also go through it once I'm finished. So once I've finished, creating graphics. Now let's continue. Again, the textbook remains the same. The 3 things you should read. And there are a lot of videos. Well, let's skip. And the reading list remains the same for the anatomy of function, scope, and parameters. That's it. Okay, so it's all about, videos. So there were all videos. Now reading, the same thing. And there are optional examples. Let's mark this lesson completed. Now let's create scene with functions. Okay, so it's like a scene and our goal is to create something like this. And this function is already doing quite a lot. So let's try by running it. Okay, so it's actually creating a cloud. How it is creating a cloud? Well, we'll see that. And it's a lot of codes. But let's start by first, seeing our canvas width and height. That is 400 and 300. Let's minimize this. Let's minimize this terminal. Our cloud width and cloud height is something that is defined so that we can create actually the cloud of the same size. Okay. Now trunk height and trunk width, that means we have to create a tree as well. And the trunk height and trunk width is already defined. Leaf size is already defined. Okay. Now tree bottom, or whatever the bottom is nothing but canvas height minus 20. That's where trees should start from. Yeah, it is starting from canvas minus 20. Because it is, you at uniform distance from this y, the height. All right. Looks nice to me. Now inside this main function, what we are actually doing, we have created a draw cloud function. Okay. That takes the canvas first of all. And since you already might be familiar with, well, parameters, arguments, and all those things. So this shouldn't be quite unfamiliar to you. If you're not, well, go through that reading first of all. And this is not very complex. So yeah, you'll be able to finish it quite quickly. So these are all our arguments because we are calling this function that is draw cloud, and draw cloud is defined somewhere around here. If we run it, will it cause a problem? No. So we can do something like this for our clarity purposes. So this first line is creating the canvas. This second line is actually drawing the cloud. And we can say draw cloud at any number of times. So we can call draw cloud again and again. So the to-do that was saying draw 2 more clouds. Well, we have actually drawn 2 more clouds. Let's cut it and put it up this to-do. And now we have to draw 3 trees as well. But before drawing, 2 clouds, let's see what this 140 and 10 is. So we're actually passing the canvas. Why? Well, that's important because canvas is defined at the main function. So when we are actually using it inside this draw cloud, it goes out of the scope. So to introduce it back, we are saying, well, take the canvas as a parameter. And we are also passing the canvas, the same canvas that we have defined as an argument. And it takes it. After that, we are also passing the x and y where this cloud should be defined. So it's 140 and 10 for now. How are we using it? Well, we are using it like cloud bottom start at y, which means y plus one third of the cloud height. Cloud height is already defined around here. Yep. Now cloud bottom end y is nothing but y plus cloud height, and I think y1, y2. Now this is x1, x2. So start x is somewhere around here. Start end x is somewhere around here. All right. So bottom two puffs, which means we are creating, ovals, and we are first of all let's not create the top puff so that we can actually try and see the ovals. So this is our oval, two ovals that are intersecting at this position. And if we create the top puff, which means this top puff will uh, be on the top of it, like on z index it'll be over it or above it. So we are not actually seeing this where the two oval actually intersects. This will actually just, yeah, it looks something like this, like cloud. How are they doing it? Well, they are defining the x, that is what we are passing. And to create the cloud bottom start y, well, they're already defined by the y. And then x plus whatever the 3/4 of cloud width is, and then cloud bottom end y, which is already defined over here. And then the color, nice. So it's the first oval. If we, comment the rest of the ovals out, we'll actually able to see it. See what? We actually also commented this parentheses. Now we've got one oval, and it was created because our x was defined. Well, not defined, but actually passed. This is our x that we are using over here. The cloud bottom start y, well, it is calculated right over here. The x plus whatever the 3/4 of cloud width is, that is, a constant at the top. And cloud bottom end y is already given, and the color is also given as an parameter. So after creating one oval, we are actually creating the another oval that looks like this thing, where the first x1 is nothing but x plus 1/4 of cloud width. The y1 is cloud bottom start y. The x2 is x plus cloud width, and the y2 is cloud bottom end y. Now don't be confused by this name, because they are naming it something quite crazy, but it looks nice. Now color is this. All right, now the top puff, it's nothing, uh, actually the same thing. But if you remember, we were actually creating three clouds. It doesn't look like a three cloud to me because I can only see one cloud. What is actually happening? Well, you might have caught it. The colors are the same, the coordinates are the same, so we have to actually give it different coordinates. Let's say something like this. So now we've got another cloud. Our third cloud is the same thing. So we actually have to do a bit of a different thing. Canvas width is still 400. So how about I say 240? Okay. Well, 280. And we've got clouds. Now instead of going till, 100, let's keep it 10 so that they are uniformly on the same line. And they are. Instead of 280, let's do something like 260. Okay, let's do 70. All right. In the middle. Yeah, now they look quite nice, I would say. Now we also have to draw trees. How do we create a tree? Well, it looks like a circle that we are creating. And for the trunk, we've actually got, the trunk. So a brown rectangle. So let's do that. So for trees as well, we have to define, first of all, let's start by defining the draw tree function. Oh, def draw tree function. Now let's call that draw tree function as well. Let's keep it at the top, shouldn't we? Because we are actually defining it right now. So we should be able to define it and use it simultaneously. So draw tree function, it should take canvas. Why? Because, well, because of the scope. So if we call, draw not cloud, but tree. And if we don't pass canvas, it won't know what the canvas variable is. And it won't be able to create anything out of it. But since we have given it canvas, it will probably work. We have to probably give it, the X and Y axis as well. So let's give it a X and Y right over here. X and Y, and probably a color that if we define whatever the color is, it will create an oval or a circle of the same color. Oh, we've got an AI, I guess. And it is trying to help us, but we will create everything by ourselves. Don't help me. Don't help me. Nope. So now what we want to do is, well, since we have a draw tree, we should actually create two things. So we can say canvas dot create rectangle, and that will create the trunk. So let's say the trunk, so it should be first of all x1 y1 x1 y1 x2 and y2, sorry, and the color of that should be brown, a constant brown. So why are we taking this parameter as color over here? Well, because we are also creating an oval that will look something different. Instead of creating rectangle, we want an oval right now. And that should actually create a oval of the color that we are defining, isn't it? And that should have a x1 y1 as well, but we can't name it the same thing. So let's say cx1 for circle of x1. Let's say cy1, the same thing but for y2s. What is happening? Okay. So now just we have to define what the x1 y1 is, x2 y2 is, and we are good to go. Okay. So what does cx1 and y1 should be? Well, how about we code it somewhere around 100? Well, let's say 10 and 100 for now. For x2, let's take cx x1 and let's add somewhere around 20, and let's take cy1 so that we don't have to calculate the 0.2 every time. Let's add 20, and if we run it, it'll create a problem. Why? Oh, there's a missing comma over here because x1 and y1 is not defined. So let's define x1 and y1. x1 is equals to this, x2 is this, y2 is this, and y1 is this. So what should be the x1? Well, it should be 10, let's say. Y1, well, let's create 100. Or, or, let's keep it that way only. All right, x2, well, it should be of the, little width. So we can say x1 plus just 10. But for y2, it should be long. So we will say whatever the y1 is plus, well, whatever the length should be. So let's 50. Now, if we run it, we actually got a problem. We have not defined what a x1, x and y should be. So let's give it a dummy numbers because we are not even using them for now. 10 and 50, and there are dummy numbers. We are not using them. Now, what is the error? Because color is also not given. So let's give it a color. Okay. And now it should actually run. Now what happened? Oh, shit. Damn it. Color should be actually the color like blue. Let's do it. And we've got something like a tree, but not exactly. All right. Now, since we know what to create and what not to create, let's see what the trunk height is. Trunk height is, well, 80 and trunk width is 20. So let's go and create them. So over here, we were doing what? X1, which means over here, X1. And we want X2, that is over here, with the same width of trunk width. So we can say trunk, not height, but width, if it is there. Well, yeah, width. And Y2 should be whatever the Y1 is plus trunk height. Exactly. Now if we run it, oh damn. You know what? I made a mistake. Well, instead of doing it over here for X1 and Y1, I made it for, well, a circle. My bad. Sometimes happens. All right. Let's do 20 for this for now. Okay. So it actually did create all these things. There's still various issues that we have to solve, isn't it? So what should be our circle? Any ideas? How do we define our circles? Why 0.2? Is there any leaf size? So yeah, we've got a leaf size. So if we, instead of adding, 50 directly, we can say whatever the leaf size is, well, that should be our defining thing for 0.2. So we'll define 0.1 and the 0.2 will be defined automatically based off the 0.1. So 0.2 will be defined by saying whatever the 0.1 is, just add leaf size to it. That's it. And now the problem is nothing but what should be, the x1, y1, and x2, y2. Because trunk should not start where our 0.1 for the circle is starting. It should not even be, the beginning of it. The trunk should be created first before the leaf. So let's cut it. Let's paste it. And now the trunk should go, behind the circle. What happened? Oh, indentation problem. Let's solve that. And now what happened? Well, this was a error. Color. Color is a variable or a parameter. Yep. Now it looks nice. I shouldn't say look nice, but yeah, it does look somewhat comprehensible now. But still, what we are getting is X and Y. But for drawing trunk, let's say we are drawing trunk over here. We are drawing trunk in quite a nice way. And over here, we are drawing leaves. And what is the issue is it's not dynamic at all. If we say draw tree again with a different values, it will not work. You know why? It will create the same tree at the same place because it is getting hard coded. So what if we change something, you know, from the starting point? So let's take this X and Y as a starting point, and let's start by creating our circles from those starting points. So for Y1, let's take Y. For X1, let's take X, and let's take it. So we've actually got somewhere. Yeah, this is nice. But for our trunks, we are not going anywhere. So we should irrespectively make the, trunks somewhere around this CX and CY. So let's say CY1 should be where our trunk should be placed. C of Y2, sorry, X1, my bad, should be where our trunks should be placed. So if we run it now, what's the issue? CX1 and CY1 are not defined. So let's define all of these over here. We'll say the variables of circles and this should be the variable of trunk. Now this should work probably. And it works. And now this is quite dynamic. Like if we try creating a draw tree at a different position, it will actually draw another tree. And if we draw a tree at another position, it will actually draw 3 trees. So we need to draw 3 trees as well. Isn't it? So we've got 3 trees. Oh, sorry. This should be 150. And this can be 10. No problem. And instead of being somewhere here, should be 210. A safe distance. Yeah. But these trees don't look like a tree to me. The rectangle is starting from here. The circle is also starting from here. What if the rectangle starts from here at this point? You know, that should be, so to solve that problem, let's, create a pen and pencil so that we can solve that. So instead of writing on top of it, let's write here and imagine this is the leaves, the square for the leaves. Inside that there is a circle. So this is where our starting point is over here, isn't it? And this is a, well, X and Y, and our ending point is nothing but X plus leaf size. I'll say LS, leaf size, and Y is y2 is y1 plus leaf size, isn't it? So this is a circle. Now instead of creating a rectangle for our trunks around here as well, from here to here, instead of doing that, what we should do actually, we should start creating a trunk right over here. How can we do that? We want to go somewhere, this is our width, which means this is our y2. And what is y2? Well, what is this width? It is nothing but, this y2 minus y1. So we'll get the width, this width over here. And if we do, divide it by half, we'll probably, we'll probably get somewhere. So let's take it and make it as our starting point. So instead of making starting point right over here, what should we do instead? Our starting point should be around the width of leaves, which is equals to nothing but the y2, which is for circle. So we can say cy2 minus cy1. This is our width of leaves. And from width of leaves, we just want our, well, x1, y1. Let's try, by typing width of leaves first of all, directly. Let's run it. Do we see a change? Well, now everything is at the same place, at the one place. Isn't it? Because width of leaf remains the constant. So we cannot just, use the width of leaves to calculate everything. We have to vary it somehow so that we could use it dynamically. And that is already defined somewhere around here, 3/4 and all those things. There's all the calculations that we can require, but still, let's say width of leaf is nothing but related to x somehow. Shall we add it? Yeah, this gives us different width of leaves, but doesn't take us anywhere else. If we say, whatever the y is, let's add width of leaves as well. Does it take anywhere else? Well, it takes us somewhere around here. Now, instead of adding, how about we subtract it? Okay, so it has shifted quite a lot. We are seeing the trunk 2 and trunk 3. We are not seeing the trunk 1 at all. Now we are seeing the trunk 1. Okay. Now instead of width leaves, how about I divide it by 2 first of all? Or should I divide by 3? We'll see that. But now it is quite close. Quite close, I would say. And for y as well, what if we used divide by 2? What will that do? Sometimes it's, either calculation, sometimes you just try it out. So it should not be by 2, but let's say by 3. Okay. How about we subtract it? Because it's going above. So that doesn't work at all. Adding it doesn't work. 6. Right. So no division at all. This looks nice. But how about we are getting x, we are getting the width of leaves by 2. That is somewhere around here, at the half of the circle. But we should not start from the half of the circle, but a little behind that. Isn't it? And that little behind that will be defined by whatever the trunk width is. So trunk width, so if we subtract trunk width from it, why do I get trunk height? I should get trunk width like this. Will it change something? Yeah, it changed a lot, but not for, you know, subtracting it with the whole trunk width, but half of the trunk width, a little bit, isn't it? Now it is at the center that we actually wanted, isn't it? And if we subtract 10, 10 is quite a lot, but let's do 10. Now it goes inside the circle so that we don't see the boundaries that we were seeing earlier. Uh, Let me show you what I'm talking about. So we are seeing certain, whites. It looks like a rectangle and the circle on top of it, isn't it? But it should actually merge like a tree actually. So we can do 1 and it also does the same thing. So 1 is nice. So I think this is quite done in itself. What can we do more is make it look quite proportional according to our own eyes. So for our case, the circle looks like the circle here, but the trunk looks quite long. So that's why I made something like 10. Still looks quite long. How about 20? Now looks quite short, but we still need a little bit shorter. It's just a guesswork. Now it looks quite similar to me, isn't it? But is there any ratio? Like 30 is this 30 somewhere? So if I see what the trunk height is, it is 80 and 30, if we try relating it to somewhere around 40, we can directly say trunk height divided by 2 and we should subtract that. But that's not happening. So we can say something like trunk height, instead of dividing by 2, let's divide it by 3. That should work. I hope so. Because I don't want to write a random number. So yeah, this looks quite proportional. If I would say something like 2, it would become quite short because it would be 40, isn't it? We are subtracting 40. But if we say something like 3, then it's 80 divided by 3, which is somewhere around here, which looks nice, I'd say. And we have got 3 trees. Is there any doubt? Well, there should be a lot of doubt if you're not doing it by yourselves. It look nice. It looks nice. Is there any other variables we could use? So cloud width, we have used it. Cloud height, we have used it. Actually, it was already used. As for the trunk height, we have used it. Trunk width, we have used it. Leaf size, we have used it. Tree bottom Y. Tree bottom Y is something we have not used. Let's use it. So it is saying that bottom Y should be at similar distance, which it is because we have hard coded the similar distance as 150. But it should not be 150. It should be whatever the tree bottom Y says. So we can take it as is. So we can say tree bottom Y, cut it, or sorry, copy it. And we can use it as a Y instead of writing it hard codedly like this. Oh, damn it. Okay. I made a mistake. And it was not a mistake, but yeah. Hey, let's copy and paste my mistake. So now this should work. Oh, whoa, what happened? Damn it. Yeah. My bad. This was our, point 1, not point 2. And we want tree bottom Y at our point 2. So let's undo it all. And let's figure out where the point 2 for the trunk is. So point 2 for the trunk is around here. Okay. And it is getting defined based off whatever the x1, y1 is. Isn't it? So what can I say? Should I even use it or not? Where should I use it? And how? 3 bottom y around here. It should be. And I cannot hard code it, otherwise it will be quite wrong. What is the 3 bottom y? Yeah, it should be this. So it is like we should stop our dependence on y if possible, which I don't think it is. So let's not use 3 bottom y since it's unnecessary. We can make it constant by our own selves, but all right, 3 bottom y is something we have not figured out. Well, we have not thought about where to use 3 bottom y. All right. So it was a planning mistake. If instead of y2, if I directly say 3 bottom y like this, well, okay. So it actually worked. But the trunk height is now unnecessary. Why? Because trunk height does not define anything at all. You know why? Because if I change this to something like 100, the trunk height will not matter. It will elongate the whole trunk height because y2 is now fixed. See, is this how we want to define our y2? If we want to, well, we can. There's no one stopping us. But then trunk height should also matter, no? So if we've got y2, why can't we define y1? But we've got y2 only because y1 was already defined properly. Okay. So let's just for the sake of it, let's try doing it. So let's comment our y1 and y2. Let's create another y1, and since y2 is already fixed, that is 3 bottom y. Let's try doing something with it. So we can say y1 plus whatever the trunk height should be. That should be a y1. How about that? Oh, what just happened? Okay. So not plus because plus would take it down there, but minus because uh, 3 bottom y is around here. We want to subtract so that we can go inside, not outside. So subtract the trunk height so that we can get our y1 around here. Yeah. Now we've got our trunk height, but if we don't somehow relate it so that, you know, it remains constant with our 150, it will create issues because leaves cannot flow or float on air. So it should be something around here. But now it is not very dynamic. So what should we do? Well, how about doing nothing at all? That would be fine. Now we just need to shift it on x-axis around here so that the third tree is somewhere a little farther, right, like this. Okay, and the colors should change. As for the draw clouds, well, we should change a little bit of y. So let's keep it somewhere around 20. Let's keep it for 15, isn't it? 15. This will remain, since this is the first one, let's give it the sequence. So this is the first one and it is a little below. So we'll make it 20. This is the second cloud. So it is at 10. This is the third cloud. So it is at 15. Let's try running it. Okay. So the position looks a little bit same, but we have to make it more. $25. Let's make it 40. Now let's run it. And now it looks quite differentiated. Now we just have to name it. Now what are the names for the colors? Can I get a suggestion? What are the names? Okay, but I want the names. I want the name. So salmon is this one. I hope this one is pink and the another one is purple. I'm not very good with colors, but all right, let's do it. So purple. Yeah, it's purple. The first one is pink. Let's say pink. It's pink now. As for the trees, well, we've written trees like something like this, but it is not always like this. By which I mean, we should change the colors of the oval or the circle that we have. So the trees can be in different colors. The first tree is green, like a tree. The second tree is, well, it's red. So we'll say red around here. Okay. And the third tree is yellow. So if we run it, oh, it's not yellow but orange because this looks like a different color altogether. Okay, so I'm not that bad with the colors, but yeah, it's all right. I hope so. So let's check for the correctness. Okay, so it's self-graded. Oh, all right. So let's submit it because it's looking quite similar, I would say. Quite similar to this. So we can go on and move on. So submit onwards. So scene with function is done. Let's do the quilt. Okay. So we've got this assignment that already has lots of code. So let's try running it. And that creates this pattern of the squares, isn't it? So what do we have? We have here something like draw square patches, and that's it. We are creating square patches. That is this. And we have draw circle patches that we have to define. So to define that, we'll directly define it. All right. But before even defining it, we are actually using it. Nice. That's nice. So let's define the circle patch. What should we define it? So we've got the starting point, the starting point that is start X and start Y. And to get an ending point, we were using patch size. So like, is patch size same for the circles and the squares? And I hope so because they are of the same size. So we can just call this end x and end y directly. Now do not get confused because this is our point 1. So this is x1, y1. This is our point 2, that is x2, y2. If you want me to write it like that, let's write it like that. So this is our y2, this is our y1, and start x is, well, nothing but x1, start y is nothing but y1. And this shouldn't be y1 but x1. Sorry, x2. My bad. Sometimes it happens. As for over here, instead of taking start y, we should take y1. Instead of taking start x, we should take x1. And that's it. That's my way of, creating something like this. Now, since we've got x1, y1, x2, y2, which means 2 points, we can actually plot a circle. Now, to create a circle, we can use it like this. But let me see what they've did for, creating the square patch. They've created 2 circles. I don't know why. So it creates a circle, start x, start y, end x, end y, which is of color purple, and then draws a smaller white square on top of it. Okay. What they're doing is, so let's see what they're doing by commenting out what they were not trying to do. So they're actually creating a rectangle which is proper purple. But, outline can only create an outline, a thin outline. We cannot decide what the size of outline should be. So to create a thick outline that should be purple in color and the square should be white, what we did was actually created a rectangle that is a white rectangle that will go inside that boundary. Sorry, inside the first rectangle as the second rectangle, which will create an effect that will look like a boundary. So that's it. Okay. So inset was nothing but the boundary we were talking about. If we create it out something like 50, yeah, it just disappeared. How about we make it 25 so that it is visible also, but yeah, it's now a little thick. Nice. But we just have to create, our circle patch. So we've got x1, y1, x2, y2. So why not just define a circle? So let's say canvas dot create circle, isn't it? Oh, there's no create circle. There's oval, not circle. And then what we can pass is x1 that we've got, y1 that we've got, which is nothing but 0.1. Now we can say x2 that we've got and y2 that we have got again. That's it. This is a 0.2. And the color should be, well, it looks like salmon because we have worked with salmon again. Not Salman, but salmon. Yep. And now we've got the quilt. But something's different. What is? Well, it's only in row 1. We want a row 2 as well. And why are we not creating it in a loop? I don't know. So instead of, well, for the first row, if we are creating it something like this, how about we try creating it in a loop? So let's comment it out. Let's try for I in range of whatever. So let's go to 0, 1, 2, 3. Let's go till 4. Let's do this. Comment it out. We'll actually erase it. But yeah. So we've got canvas to get a patch size. What is a patch size? It's a variable that we have defined. So let's pass the patch size instead of 0. And now somewhere this patch size is 0. All right, somewhere it's patch size, just whatever it is. And the sometimes it is patch size times 2 and then patch size times 3. So we can replicate that by multiplying it by I, because I starts from 0. So first of all, the path size will be multiplied with 0. So we'll get 0. Let's erase these. So path size multiplied by 0, we'll actually get 0. Then path size multiplied by 1, we'll actually get the path size. And then path size multiplied by 2, because I is now 2. And then I is then 3. So we've got the same effect, but inside a loop. And this also looks nice as well. So perfect, as I would like to say, perfect. And if we run it again, oh, whoa, whoa. What just happened? Okay, okay. So what just happened was we created only the square patch, but it was going randomly. Like it was going square patch and then rectangle patch, or sorry, circle patch. Sorry, my bad. And so can we replicate something like that? I hope so, but we'll need a condition. So what should be the condition for creating a circle patch? Right now it's a mess. Right now it's a mess, isn't it? So to create it one by one, we need to check for I. So something like, if we try noticing, the square patch is first of all 0, then it is times 2. So if I is even, which means 0, 2, 4, 6, something like that. So if I is divided by 2 and we get a remainder as 0, what we should actually do, which means it's a even, we should draw the square patch. And else we can actually try drawing the circle. Now it should work properly. And this worked properly. And now we are not writing it 4 times or 5 times or whatever times we should. We are just creating it. And it's not even hard coded. All right. So this is our row 1. Now how to get the row 2? So to get a row 2, let's first hard code it, isn't it? Let's see what we can change over here to get our row 2, which is not a very nice thing, I would like to say. But yeah. Now to get a row 2, what we have to do is canvas x1, y1. So for row 2, what is changing? Well, y1 is changing. So y1 already, first of all, was, 0, because y1 was 0. Now it is y1, instead of being 0, it is what? This is of size path size. So we can say path size. And if we replace all the zeros by path size, I hope we'll be able to get our row 2, isn't it? So if we run it, we've actually got something that is row 2. But, what is the problem now? The circle patch, first of all, we are starting by the circle patch in the row 2. So this should be over here. And then we are getting square, then we are getting circles. And now the path size should be times I, which means this should start by 0, first of all. And this should start by path size, that looks like this. This should, instead of being 3, it should be times 2, because this was 0, 1, and this is 2. Now this should be 3. And this will give us the row 2 like this. So can we create a loop out of it? Absolutely. We just have to copy this loop for the row 2 and we can paste it. Over here, we have to say path size. So let's copy this path size. Let's copy this path size, paste it for the zeros so that our y has changed. So now if we run it again, we'll stumble into the same problem. That is, well, the order. we should first of all create the square circle patch in the row 2 and then the square patch. Now, in the for loop, it was quite easy to solve with this, and we did it, isn't it? So how about we check for the correctness and move on? And we did it, so let's move on. So we have created the quilt. The optional challenge is pyramid. That one, pyramid one, was quite a challenging problem, I would say. So, first of all, this is what we want to create. A pyramid that is, has a brick width of 30. So each brick has a width of 30, and then brick height, and every brick has a height of 12. And the brick in base, which means the bottom row of the brick should be, 14 bricks. And after that, it should be 13, then 12, and then so on. All right. So that's what we are doing. And it has only given us the hint of, create rectangle like this. So I tried a lot of things, lot of ways. And this is a very rough way to create the same thing. But it works. So just let it work, isn't it? Let's not change anything out of it. But let's see what I tried. First of all, I tried 2 loops inside each other, a nested loop. So I created certain variables so that I could just directly place it inside our x1, y1. X1, I would say. This was a variable 2 that was, calculating how much of distance should there be from this position that looks like x is 0 to this position where it is x is 90, because I remember it. Why? Well, we have calculated it. And how did we calculate it? Whatever the canvas width is, which is 600, minus whatever the bricks in base is, which is 14, times bricks width, which is 30. So 14 times 30 will give us, let's get a calculator. So this is a Python. We've got a calculator. So let's put all the values. Okay. So we've got canvas width, which is nothing but 600. So let's put 600 there. Now we are subtracting. What are we subtracting? We have bricks in base, which is nothing but 14. So we can say inside bracket, we have bricks in base, that is 14, times whatever the bricks width is, that is 30, isn't it? And that we are dividing by 2. So this thing, we are dividing it by 2. Where did I arrive to this problem or this conclusion? Well, I tried creating a formula. And then we are subtracting whatever the brick width is and times I or j. So yeah, over here j is not defined, but let's do this. And we have got 390. But if we go on calculating for the first brick, that is, 390 minus whatever the brick width by 2 is, times the j in this program. So for me, it worked somehow by saying 600, and then 600 is the width. And let's open up pencil and papers. That's something that I like. Okay, so this thing is 600. Let's write it. Now what we've got is this thing, this x, isn't it? So let's call this position, this gap, as x. But if you look properly, look closely, this x is always over here as well, at the same distance. So we've got x and x, so we can call it 2x. So this is x and this is also x. We've got 2 x's. Now why did we got 2 x's? Because the bricks in base, which is this long, this long, this bricks in base is nothing but, if I can write properly, it's nothing but how many big bricks are there. So there are 14 bricks in the base times what is the width of a one brick. So if we multiply it by all the 14 bricks, we've actually got this area inside our mind. So if we do something like 600 minus, 14 times 30. So 600 minus 14 times 30. So what is 14 times 30? Well, it is 420. So if we say 600 minus 420, well, we've got 180. And if we say that we want our x's, well, we've got 2x because, if we subtract this much area, let me get a line. So if we subtract this much area from our width, what we are left with is nothing but x, isn't it? This area is x. This all area is x. And this area is as well x. So what is left with us, that is 180, is the sum of the area of this width of 2x. So if we divide 180 by 2, we've got 90. So the x over here, this x or this x is actually 90. So just keep that in mind. So this is what I was trying to create, not just for this one row, but for all these rows somehow dynamically, which didn't work out quite well, isn't it? So then I created something very hard coded or something very stepwise, I would like to say, and it actually worked. And there's a lot of trial and errors. So let me first of all show you my first thinking or the first approach to this problem. So what I actually did for this first problem was to not do anything for the canvas, but actually use the terminal. So I actually used the terminal. So inside the terminal, let's clear it. So inside the terminal, what I did was I actually created these sort of triangles out of this square or the characters, isn't it? And this is very easy compared to what we are going to create out of the graphics. See all these patterns. So I tried creating all these things using loops inside loop, nested loop, to get an idea around how can I use a same function to lay bricks somehow that is what I want in a pattern. So let's erase this. So I tried a lot by getting variables x1, y1, x2, y2, and then creating a rectangle. And well, I printed all the variables, for diagnosis. So let's uncomment this first of all, so that we can see what we were getting. If we run it, we've got a actually error. What is the error? Okay, so we did not uncomment these lines. So now if we run it, I actually got this much, which is half clear because in the base we are getting 14 bricks. Above that, we are actually getting bricks, but it was, not decreasing. Like bricks were not decreasing. This is 14 bricks. Above that is also 14 bricks. Above that is also 14 bricks. I somehow wanted it to be 14, 13, 12, 11, 10, 9, and so on till it is 1. And it was not happening using this code. I don't know why, and I couldn't figure it out. So, well, I just commented out, and this time I'm just going to erase it. And I created something like this, where I've created I, n, x1, y1 as different variables with different things. So n is nothing but bricks in base for now. So we can say brick in base, but it wouldn't change anything. And then after doing this, I actually hard coded. Hard coded what? Hard coded a function that is lay bricks row. So if I uncomment these lines, Okay. And the function lay bricks rows. This should work now. So I hard coded the values so that I start, you know, printing bricks row by row. So this is a brick uh, in the first row, I would like to say, as 14 bricks. Then above that, we have 13 bricks. Then above that, we have 12 bricks, and so on. And since now I got a pattern out of it, so instead of doing it very hard coded way like this, instead I created a while loop like this, where it actually started, you know, printing or laying the bricks row and updating all these variables I, n, x1, y1. Let's keep it like this. All right. So after printing one row, it'll update it, like subtracting by one, adding by one, something like that. And why this magical number 90 came from? Well, because we've calculated it and it's hard coded right here. And we've got a pile of bricks. Now, if you want, I can create it from the base up. So this was a summary of how I did it, what I did it. Let me give it a try again at this problem, isn't it? Okay. So since this is a magical problem, let's give it a try again. So let's give it a shot again. So we've nothing. We've got a canvas and, well, nothing at all. And we want bricks. That is 14 bricks. Now to lay a brick, it's nothing but we can say canvas dot create, and we can create rectangle. And to create a rectangle, we want x1, y1, x2, and y2, isn't it? And the color. So color should be yellow. And for x1, y1, let's define it by, hard coding it first of all. X1 is 0, y1 is again 0, x2. Now, instead of just hard coding x2, we know a lot of things that we can, depend on x1 for our x2. So whatever the x1 is, if we add, bricks width to it, if we add bricks width, which is 30 to it, we'll probably get our x2. And to get y2, it is nothing but whatever our y1 is. If we add bricks height to it, we'll get our, well, y2. And it's not bricks height, it's brick height. All right. Now, if we try running it, there's a issue, that is, well, canvas, canvas. Okay. And we've got a brick. But is this how our bricks would look like? No. There's an outline as well. There is a black outline. So let's create a black outline. So to create a black outline, we just have to say outline, or directly we can say black. And that will create a black outline like this. And we've got a brick. Nice. Now, after getting this brick, what do we want to do? Well, we want to position it somehow around here. But before that, let's think about how can we change, our x1 and y1 so that we can get all these sorts of bricks at different positions. Let's think about that. So if I change x1 to 10, what happens? Bricks shift. If I change it to, well, 90, what happens? It shifts a lot. And for y1, can I do -0? That doesn't change anything. Well, what if I did something like canvas height, which is 300, isn't it? Minus whatever the bricks height is, which is 12. Will it come at the bottom, right over here? And it did. So this is our starting point. So we can actually play with x1, y1, and we will actually get, you know, a bricks. So we can just use this as a function. We can say lay bricks. So it lays bricks. It lays a brick, so we'll say lay brick, not bricks, isn't it? Now we can pass on x1, y1 as is. So we can say x and y. Well, let's name it x1, y1, isn't it? And we should also pass the canvas, because if we don't, let's see what we get. Let's try not passing the canvas and we'll get something interesting. That is, oh, whoa. First of all, we are not actually calling anything at all. So let's start by calling this lay bricks, and then we'll get a problem, isn't it? Lay brick. Now we'll get a problem if we don't pass canvas. Let's see. So it says name error. The name canvas is not defined. Did you mean canvas? That is, imported from canvas. Your code has an error. We are crafting an error explanation. So it now tries to figure out what the problem is. So it says to fix this, you can either pass the canvas object that we have defined at the line 12 as a parameter to the lay bricks that it needs. So to define a parameter, we come where we define the lay brick and we pass on the canvas with a proper spelling, isn't it? Now it will work? No. Because now this time we've got a parameter, but we've also have to, pass this as an argument inside the argument list. That is where we are calling this function, that is lay brick. So over here, we have to pass canvas again, as we usually do. But yeah, sometimes we take it for granted and we forget to pass the canvas and we stumble into these errors. And I wanted you to see what these error looks like and what do they mean. Okay. So what happened now? There is a comma, I guess. So we've got the same brick. Okay. But now we can change this x1, y1 in a loop, and this will change the position of our brick, isn't it? We can lay brick in a loop at any point of time. Let's do something. Let's do something out of it. Let's lay brick inside a loop for 14 times. So if I say for I in range of 14, let's try by laying bricks. But every time you'll lay brick 1, that is x1, it will multiply by not 1 but I. Let's see. Okay. This is not expected, but we've got this. Why this happened? So I goes from 0, 1, 2, 3, 4, 5, isn't it? But we want it over here, first of all, 90. And then we want, plus. Okay. So there was an error. The formula has an error. We have to add this length to it, times 2, times 3, times 4, and so on. So we can say, well, give it a distance of 90 to lay a first brick. But, whatever the brick width is, that is 30. So let's say brick width times I. If we do that and add it, we'll probably be able to get x1 properly. And we've got our first row of bricks. Okay. So if this is our first row of bricks, how can we get the second row? Can we just copy and paste? And say something like, well, give me, instead of 14, give me 13 bricks. Will that change anything? Not 34, but, well, 13 bricks. Will that change anything at all? Well, for now, it won't, because y1 also has to change. So y1 is similar, so it is, creating 13 bricks on top of it. So to change y1, we just have to say the same thing. That is, right now it is saying whatever the canvas height is. So let's write it properly. Canvas height. I hope the spelling is correct. And we are subtracting, bricks height. That is 12. So we'll get our first y1. But to get a y2, we have to subtract the bricks height 2 times, and then 3 times, and then 4 times. So we can multiply it by, well, I. Will that work? I don't think so, because we should not multiply it by I. That's our bad. This will create a ruckus. But let's do it anyways. So it does something like a staircase. We don't want a staircase. We want something like, well, a row. So something like this. So we've got a brick, and this is now 13 bricks on the second row. But there's still a thing that we are missing. What are we missing? Well, it shouldn't look like this. It should actually, the x1, that is this, the magical number that is 90, should also add something, something that is half of whatever the brick width is, that is 15. Why? So that it comes in between. It starts from between the first brick that it laid. That was at 90 distance. Now it should be at 105. So like this. That's why we added 15 to it. Now to write 15, we can say whatever the brick width is times 2. This is what we did. And if you think about it, this was also over here, over here. But it somehow got multiplied with 0, isn't it? It got multiplied with 0. So that's why we never saw this brick width by 2. But over here, we can say it got multiplied by 1. Isn't it? So if we run it, we'll get the same thing. But now these two statements, the x1, y1 looks quite similar, except for y1. Let's make it look similar as well. And instead of 2, let's make it 1. And now it looks similar. Okay. So if we somehow can get this 0, 1, and all those things after laying the bricks. So let's say if we laid the whole bricks for 14 times, isn't it? So if we laid all the bricks 14 times, then we want to change for the second row over here to something like 1, and the bricks height should change to 2. Can we do that? So for that, I tried for loop, the for loop, the magical for loop. But for loop inside a for loop. Okay, so it went something like, if I can, comment these out, well, copy and comment these out. Because I've always wanted to use for loop for this, not a while loop that I actually used. That looked quite messy, but it worked, so I let it remain like that. So for j in range of 14. How about, not using j, let's use I. So what this does is it lays the bricks. We try it to lay a brick, and this will move up a row. This is A. So the I will try laying the brick. We've got an error, that is a colon. And then we've got an indentation error. So let's fix that as well. And now this should work, but there's an issue. That is, it is only laying the first row. We somehow want, it to change for A and I. So how about we print A and I and notice what we can use? Print A and I to see what we can actually use. Because we know what to multiply, but let's see what behaves like that. So if we run it, so 13 remains fixed, isn't it? So for the first loop, the 0 remains fixed, and then the 0, 1, 2. So I quite changed. So if we want I to change, it should change, and it did change, but the 0 remained the constant, isn't it? So for 0, if I can say A, will that make a difference? And over here, there's a 1. How about I make it something like A plus 1? Isn't it? Will that make a difference? Let's see. So, well, it did make us difference, but not the difference that we wanted. We wanted it to, lay a brick and move on. But it laid a brick, but the number of brick didn't change. Don't know why. So let's see. Again, let's see. So there's 13, 13 at the end. So what we are doing is we are saying brick height times 14, which we never wanted. And for I in range of 13, well, this actually never was achieved. So we want, our first brick to be laid 30 this many times. What is it? I want my first bricks to be laid, well, 14 times. Then I want this first bricks to be laid 13 times. Then I want it to be 12. Then I want it to be 11. How can I do that? How can I do that? Well, to make that change, I can't figure out. What should I do? So, how about instead of writing 14, I write it like A, and I name A, not A, sorry, A is already used. A variable is already used. Let's use N. So I want N times bricks to be laid. So what if N is, 14 for now? 14 was the first thing. If it runs like this, so it runs. And after this loop ends, like over here, I update N to 13 and then 12. So I subtract 1 out of it. So we can say N is equals to nothing but N minus 1, or we can properly write it like a shorthand, that is N minus equals 1. That is the same thing, like this. Will that make the difference? And it did. Yes. So yeah, every time we try something different, we make something different, we improve our code, and we improve in our lives. Thank you. That's it. All right. So this was the difference we wanted. This was the difference we wanted to make. And we've noticed the pattern. What was the error? I didn't notice the error earlier because I was not hard coding it. But now I understand hard coding was important for me because I noticed the difference that was not here, but it was here in this loop that I was actually changing. Not just I, but the range was actually changing. So first we were going for the range of 14, then we did for 13, then so on. Now, if you remember correctly, there is a constant for this. That is bricks and base. So bricks and base is 14 for now. So let's, instead of using n, we can directly use bricks and base directly. And we can update this n by saying, well, whatever the n is, this is nothing but brick in base, or well, bricks, the s. But you know what? Brick in base is a constant and we shouldn't change constant. We can use it, but we shouldn't change it. So how about we create the variable n, and instead of writing 14 directly, how about we use brick in base at one place? Okay. So we've actually solved this, and okay, so what was the error? Brick. Okay, so it's bricks. Sorry, spelling mistake. So Well, I've already shown you my earlier way, which was very hard coded, very ugly, I would say, because we were creating 4 to 5, n, I, and then x1, y1, all these variables. We were creating them. Now this time we are not creating at all. We are just you know taking x1, y1, and we are getting x2, y2 that we were getting already. This function is the same. The only difference is we are only using two loops inside each other. It's a nested loop, and we are achieving the same thing. Earlier, we were using while loop, a single while loop, where we were updating all these variables. So, like a was a variable, I was a variable, isn't it? And we were updating it inside the while loop. And we did initialized it earlier. So, well, just for the comparison sake, I'll write it down, explaining the earlier loop as well. So let's comment it out. This one worked, so let's comment it out. So the earlier code went something like this. The I, which should start from 0, we could start it from anywhere, but we are starting it from 0. And then n is equals to, well, 14. And then x1 was actually 90. And y1 was actually whatever the canvas height is minus the brick side. Okay. So this could have worked at that time also, because I somehow tried using the for I and j sort of loop, but it didn't work that time. So, I gave it a try again, and this time it worked. Sometimes speaking out loud what we are trying to do and giving it a time also works for solving a problem. So we used a while loop when n is greater than or equal to 1, which is, n is starting from 14. So we'll probably update it by subtracting it by 1. So we can go something like lay brick bricks row, isn't it? And that's a different brick row function. And we were using canvas and passing the x and y. So x1 and y1. And we were also passing this n, that is 14, so that we want to, lay 14 times, 13 times, 12 times, and so on. And after, laying the brick, that was using a for loop, what we actually do, there is an indentation error. I don't know, it looks like an indentation error to me. Okay, let's take it. And after, laying the brick, we were upgrading all this I, N, and, the X1 and Y1 variable. So the I was appended by 1. So whatever the I is, that is 0, will be appended by 1. The N was actually decreased by 1. So there's a opposite of appended. What is it? Whatever. It was decreased by 1. The X1 was updated by the same formula that we used. That is, the 90, the magical number that we have calculated, plus the bricks width. Divided by 2 and times I. And then the Y1 was also getting updated to canvas height and minus brick height times I. Okay. So this was our main loop that was working for us, but we have created another function that is lay bricks row. This is not this one, it's a different function. So we defined something like this, lay brick row, and it actually used a for loop, isn't it? We can write the for loop, or instead we could just directly copy and paste. It's the same thing, a little different. Oh, sorry. Now we can write the for loop for I in range of, well, n, isn't it? And then we wanted our x1 to be well, x1 plus bricks width times I. So we can write something like x1 is equals to x1 plus whatever the bricks width is times I. The y1 was doing something similar, that it remained y1. So yeah, no problem at all. And instead of creating x1 like this, we can, create another x1 with the updated value. It's like updating a value of x1. And y1 remains the same, so no need to do anything with the y1. The x2 and y2 were getting calculated the same way. So, all right. And as for the rest, it was the same. So if we try running it, there's a syntax error, that is the colon. And colon over here. I always miss my colons. Now, what's the error? Okay. So here there is some errors. I don't know why it's not creating it, but earlier it did. So I think there is a spelling mistake. That is brick width. So if we run it, now there's another spelling mistake, I guess. Okay. So there was some errors, but now it's solved. So this was what we were doing. Okay. And it worked at that point of time. And it is a messy and it is prone to so many errors that we have seen already. It worked that time, but it was prone to so many errors. But let's erase it and let's go back to what we were actually doing. Let's, cut it and paste it somewhere else, somewhere around here, that says using while loop. And let's define it as a, function saying using while loop. So if we call this anywhere in the main, it'll actually start working. No need to comment this out. And this is using for loops. And it is also inside the main. But we can say something like define using for loop. Okay. And this n was a part of this for loop. So let's keep it there. Now if we call it, using for loop, it will work. Oh, it doesn't work. What happened? What just happened? It says error explanation. Something happened. That is canvas. Canvas is not defined. Why? Because we did not pass canvas. So let's pass canvas to it because, yeah. And now it should work. And similarly for while loop as well. So let's copy paste, make this a commented one. Let's say this is using while loop. And that will also face the same error. That is, it doesn't know canvas. So let's say canvas is known to us as run. And it is also doing the same thing. So yeah, we made pyramid using two different things. And I like this for loop one. All right. So if you want to use it, just use this for loop one. And it's nice. All right. So let's move onwards. So now it says create your own graphics, which, well, I did. So we are not going to focus too much on it, but I created I got a troll.png, and then because we've already created so many squares, circles, lines, and all those things. So in this, I just tried, creating our image sort of like this. Yeah, absolutely. So we are just getting canvas. We are saying image variable, or we can, since we are not using it anywhere else, so we can just say canvas.create image with size, and we are giving it the starting point, that is 0, 0, and the canvas width and canvas height should be its, width and height. So what I'm saying in the line 11 is its width and height of this image should be same to this canvas width and height, and it is. And which image am I talking about? I'm talking about troll.png, the same name that the image is with. That's it. So this was my image graphics. So I created my own graphics. Now attend random circle sections. So this is week 5, the graphics. So let's see. It says it has to create, random circles. So we've got our canvas width, canvas height, circle size, n circles, and we have to create circles randomly. So let's go and create them quickly and end this week 5. Okay, so we've got this, code, which has nothing except for the canvas. So we are getting a canvas. We are printing that this is, a random circles program in the terminal. And we are not doing anything except that. So let's minimize all these things that we don't want to use. Now there is a random color function. Okay, so we want to use terminal. So what this random color function does, it picks up random colors. So if we try printing the random colors, So we are directly printing the random color function, isn't it? It will give us, oh, so it gave us a purple color. If we run it again, it gives us a salmon color. We run it again, cyan, blue, cyan, blue, light blue, and so on. So it gives us random choice from this list of colors that is there: blue, purple, salmon, light blue, etc. How does it choose that? Well, we have already imported the random library. So we have created a random colors function. And this is just, a comment. This function is of 2 lines. First of all, we are creating the colors, that all these colors that we can randomly choose from. And then we are choosing it using the random.choice, and we are passing the whole list to it so that it can, choose any list using the index. It can choose any colors from the list that is named colors from any index. As for the index, you will know about that in week 6. So follow up for that. And we are returning the value. So what return value does, we can either use it, store it, or we can print it. So we are printing it in line 12. So we are getting random colors right over here. All right. So that's it for our terminal. Now let's start by creating circles. So to create a circle, we have to say, well, create circle or oval, isn't it? But where is it stored? What function is this create oval? It's inside canvas, isn't it? Now it will create oval. Okay. Now to create oval, we need again point 1, which is x1, y1, and point 2, that is x2, y2. And colors that we are getting from random colors. So we can directly say, well, get a random color from the random color function and use that color, isn't it? So now we want x1, y1, x2, y2. So for x1, I'll say, well, randomly 0. For y1, I'll say 5. As for x2, well, since it's a circle, we have to use x1. And then we have to use the circle size, that is 20. We can directly use this variable, isn't it? And similarly for y2 as well, we just have to change the number or name from x1 to y1 and from x2 to y2. Now we are ready to go. So if we run it, we're actually getting a random circle of random colors. See, it's a random color. Most of the time we are getting purple, but it's a random color, isn't it? From all of these colors in the list. Okay. So this is working, but we don't need only, one circle. We need how many circles? We need n circles, which means 20 circles. So we can probably run it in a loop saying, oh, sorry. For I in range of, n circles, and the spelling of range is incorrect. Now it's correct. Now for 20 times, it will try creating a circle. There is a colon missing. And it did. But we are only seeing the one circle. Why is that? Well, because the coordinate of x1 and y1 are the same for all the 20 circles. How can we change it? Well, it says use random generated numbers, isn't it? So we are probably going to use random generated numbers. So to get a random generated numbers, we can say, well, use random library. So we can say random, not rand int, and start from 0. And for x, we can go all the way here. That is canvas width, isn't it? Canvas width. So it will give us different x1s from random numbers. And we are getting all the 20 circles on x1 because y is same. Y is 5, hard-codedly 5. Now to get a random y as well, we can say something like this over here as well, but instead of width, we should make it height, which is same for this case, but will not remain same for every case. So we should probably follow it, HEIGHT, canvas height. And we are able to create 20 circles Now, this is what it wanted. So we can say we have done it and check for the correctness. And we did it. If you don't understand what we did, well, you should have followed all the problems, but I'm trying to explain it in very simple words. Well, we want x1 and y1, which is the starting point, randomly generated. So it should be randomly generated for all the 20 circles. So this for loop will run for 20 times, which will generate 20 different circles, and the starting point for all the 20 different circles will be generated each and every time using the same random rand int and the range. And the range is dependent upon where it is going from. So it is going from 0 to canvas width for x-axis, and for the y-axis, it is going from 0 to canvas height, isn't it? So we are getting starting point for all the random 20 generated circles. But as for the ending points, this is, well, quite dynamic, but still fixed. The circle size will decide where the ending point will be. So wherever the starting point is, that is x1, if we add circle size to it, we'll get x2. And similarly for y1, if we add circle size, we'll get y2. And we are using all of these together. And for random colors, we know how it works. We have printed it. So over here it works similarly. It returns a value of color, and that color value, like blue, purple, gets passed right over here as an argument, and that's it. So is there any problem? I don't think there should be any problem, isn't it? But you see, certain circles are going beyond, because we are going till canvas range and like canvas width and canvas height. So we are even starting, we can start when the canvas width is 300. So we can start over here as well. But the rest of the circle will be drawn somewhere around here, isn't it? So outside of this canvas. So instead of taking the starting point or the starting range till canvas width, we can shorten it by the circle size. So it should not go beyond, so that our circle does not go beyond. And if we do it, it does not go beyond for x-axis, but it can go beyond for y-axis. And we are not seeing, yeah, see, it went beyond for y-axis. This is like a half circle. So we should do the same thing for canvas height as well. So these are the starting points. We should not go and start where the canvas is ending. We should not do that. Now it will never go beyond the canvas, isn't it? It will always remain in the canvas. It can overlap, that doesn't matter. So this was our possible extension. So we had extra time. So we can try adding the following extensions. So draw a random number of circles between 1 and 20. Okay, so we can do that easily. So it says between the range of 1 and 20. So we can say random dot randint 1 to 20 is our range, and we want to generate it. The spelling is wrong, so rand int, yeah, like this. And we can say n is equals to this. And instead of running for n circles, we can try running it for n. So it will generate random circles out of 1 and 20. Sometimes it can generate 1 circle, sometimes it can generate 20, sometimes 2. So yeah, we are able to generate or draw a random number of circles between 1 and 20. That's it. Because for loop was responsible for generating 20 circles altogether. So if we generate different numbers every time, let's say it can generate either 1 or either 20. So the n can be either 1, 20, or all the numbers between 1 and 20. So we can generate different number of circles if we use it as a range for the for loop. Now the second extension is draw circle of a random size. Okay. So right now it is not a random size, it is a circle size. But if we try drawing it of a random size, we can probably, use this thing called random.randint. Should we give it a range or just a random size? Well, how about we give it a random size? Sorry, my bad. What am I doing? So how to, generate random numbers without giving it a range. So randint actually gives it a range. How to generate random numbers without giving it a range. So we want a console project which will have some random libraries. So yeah, randint. So this randint gives it a range of 1 to 100. We don't want that. Well, so I've searched it and it looks like to generate random numbers without any range, there are multiple ways, but we can always use something like random.random like this, and it'll probably work. It should work. And the same thing, you know, for this one as well. Let's do it. Let's try running it. So it is actually generating numbers, but it is very, what should I say? It is quite minute, like specks of dust. And let's fix it to 20 so that we can see a lot of numbers or a lot of circles. So there are lots of specks of dust that you might not be able to see because random.random actually generate number between 0 and 1. So yeah, that doesn't work for us. So what if we said multiply or times random.random, and the same thing for, oh, what happened? Same thing for Rx as well, like this. Okay. So it doesn't work like that. So how about we magnify it by 5 times? Or how about we magnify it 50 times? And it is magnified 50 times, but this should also be magnified 50 times. Yeah. Now we've got random sized circles. If we magnify it 5 times, what will happen? Will it be quite minute? Well, it is quite minute. How about 15? No, let's 25. Okay. So 50 was nice because it is magnifying it quite a lot. And it is also, quite random also. And it looks nice. Okay. So the second one is done as well. Third one says, draw the circle such that all parts of the circle are within the canvas. And I tried it by saying, whatever the circle size is, just do that. And it should have worked, but now it doesn't. You know why? Because we are creating random numbers. So how about we generate two random numbers differently, separately, like ry is equals to this number and rx is equals to this number. It looks same, but it is not. Believe me, it is not. And over here, instead of subtracting it by circle size, we subtract it by ry. And over here, instead of doing this, we do rx. And where are we? Over here, it should be ry. And over here, it should be rx. So what is actually happening is, oh, we made a mistake. What is it? What is a mistake? I can't see it. Hello. What is the error? Let's see the terminal. It says float object. Okay. So it cannot be float. So let's make it an integer. How about that? So let's encompass all these numbers, and we know about type conversions. So we are converting it explicitly into integers. Now it should work. And it did work. And nobody is going outside of this canvas width. Okay, so the extension is done. But you might ask, why am I taking two numbers? I could have just generated one number that is, let's say, random number, no need to for x and y, just a random number. Why did I not do that? And the answer is quite simple. It will do the same thing for two things. So it actually looks like a circle. But we didn't want it to look like a circle. We wanted to look very random, sized. But yeah, if we look like, yeah, the second statement says draw circle of random size, not draw random things. So yeah, probably my bad, my mistake. This should have been R. But over here also, we are creating two random numbers. Why is that? Why can't we just use, one random numbers? So like, how about we create another random number like RA, and use it for x1 and y1. Well, what it would create is a very diagonally going circle line. So it is starting from here, it is going till here, because our x1 and y1 are randomly generated, but they are similar. So x1 is similar or same to y1. That's why we are getting 20 circles, but it is not uniformly distributed in the canvas. It is, like this. And this also looks nice, and it is also completing our assignments if we think about it. But let's keep it how it was. But now we know we can create a lot of things, and it's quite interesting, I would say. There are actually 20 circles, but let's now generate n number of circles. So now all the possible extensions are done at the same time. And this is very nice, I would say. I'm loving it. Okay, so since it's done, let's finish this week 5. This is done. So our week 5, the attend random circle section is done. So I'll see you next time.